Hello dear students, good evening to everyone. Okay, first let me clear about the screen and sound. Is it clear? Sound and screen both are clear? Hello dear students, good evening. Okay, now start the coordination compound. This is very important chapter for your upcoming board examination. Then now start the one by one. Okay, all of you join. Then in the last lecture started the okay, that's the transition in the transition elements. The हे chapter complete झालेत. Transition in a transition element completed. Elements of group 16-17 completed. Now start the coordination compounds. Coordination compound has a weightage 5 to 7 mark weightage. This is most important chapter for your JEE main exam as well as the NEET exam also. CET also important. Get it? Now start the questions one by one. Then okay, the coordination number of the cobalt in the COCl2 EN twice plus is. Then what is the coordination number? The coordination number of the cobalt COCl2 EN twice is. Then okay, there is a written as that's a Cl2. Cl2 stand for the 2. This is monodentate, so 2. And ethylene diamine, that's a, okay, this is ethylene diamine. It is a bidentate ligand, so this is a 4. He donated the 4 electrons, so ethylene diamine is a 4, and chlorine is a monodentate ligand, so he donated the 2 electron. That's why the 2 plus 6 is a 6. 2 plus 4 is a 6. So it is the coordination number is a 6. So it is octahedral complex. This complex is a octahedral. So written as a octahedral. It is a octahedral complex. Get it? Ethylene diamine is a bidentate ligand. So as the ethylene diamine is a bidentate ligand, he donated that's a 2 electron each. So there is a total 4. Get it? Okay, there is a total 4 electron pair, and Cl2 donated the 2. That's why written as a 2 plus 4 as a 6. Get it even? So this is the 6 coordination number. Next, the correct formula of the complex having IUPAC name. This is a tetraamine. So every contain the tetraamine. Dibromo. Okay, this is a dibromo. This is Br monobromo. This option rule out. This is bromine. This option rule out. Dibromo platinum bromide. Yes. Okay, this is a bromide. So what is the oxidation state? In this complex there is the oxidation state. So this is equal to how much? So this is equal to, that's a minus, okay, plus 2. So ammonia is a monodentate ligand, it is neutral. So this is a 4 into 0. So what is the X value? So this is the Br2. This is 2 minus 1. And so platinum taken as a X. So X is equal to how much? X is equal to, this is a plus 2, and then this is a plus 4. So this is a plus 4. So oxidation state plus 4. C option is the correct. Get it? Note down. Then in the B option, what is the oxidation state? Is equal to, in the B option, this is a minus 1. So this is plus 1. So plus 1. Get it? Is equal to. This is 4 as a 0. So this is 0. And Br as a minus 2. Get it? Minus 2. And then platinum as a X. Get it? So this is plus 3. This is in the B. This is plus 3. Platinum is in the plus 3 in the B complex. But in the C, okay, there is a plus 4. So this is correct option. Pt Br2NH3 4 Br2. Get it even? Note down. This is very important question. Coordination compounds. Now start the one by one. The correct formula of the complex. The correct formula for the complex sodium hexacyanoferrate. Sodium hexacyanoferrate. Then what is the correct formula? Okay, anyone answer? Okay, the correct formula for the complex sodium hexacyanoferrate is, okay, this is sodium hexacyanoferrate 3. That's a hexacyano. So every contain the hexacyano, and then that's a sodium oxidation state. This is very important, oxidation state. If you calculate the oxidation state, we'll get the answer. So this is a sodium as a +1, cyanide -6. So Fe as a +5. Fe +5. So option A मध्ये Fe +5 आहे. Get it? +5 म्हणजे असे रोमन 5 येतील. Get it? Roman 5. Then that's in the, this is +2, this is -6. So Fe as a +4. So this is in the +4. B option मध्ये that's a +4 आहे. So this is the +4. Fe as a +4. So this is not option. Next D option मध्ये that's this is the +4. This is the -6. So Fe as a +2. So this is a Roman 2, but written as a Roman 3. So C option is the correct. How? Na3 as a +3. Cn6 as a -6. So Fe as a +3 is equal to 0. Get it? That's why the +3. So this is your answer. Get it? Note down. This is very important question. Get it even? Is there any doubt? This is too much important question for your upcoming board exam. Same type of question. Then the correct formula of the complex. How to calculate the correct formula? Just by calculating the oxidation state. Oxidation state plus, okay, +3 आना चाहिए. Okay, if the oxidation state is came as a +3, then this is your correct formula. Next question. The correct IUPAC name of Na3LF6 is. Then the first calculate the oxidation state. Sodium +3, Fe +6, so aluminum +3. So +3 is the answer. So option B, options D is ruled out because the +2 oxidation state. Get it? And then आता चेक करू आपण की ते व्यवस्थित नोट केलेत का, की यांच्यामध्ये हा कटायोनिक आहे. गेट इट? तर हा अनायोनिक कॉम्प्लेक्स आहे, त्यामुळे त्याच्या नावाच्या मागे काय आलं पाहिजे? अल्युमिनेट. अल्युमिनेट ATE. Aluminate stand for anionic complex. This is the anionic complex. Anionic complex. So A option is the correct. Get it? सर्वांना समजलं का? क्वेश्चन नंबर 12 समजलं सर्वांना? सप्टेंबर 2021 चा क्वेश्चन आहे, बोर्डचा क्वेश्चन आहे. These are very important question. Same type question will be asked in upcoming board exam. Okay, if you solve the all previous year question, yes, definitely will give the 90-95 % mark. The correct IUPAC name of the following complex Na3AlF6 is. Get it? Sodium hexafluoroaluminate. So this is your correct formula. That's a calculate the oxidation state, rule out the two option, and second is the anionic complex. So anionic complex N for the ATE. So this is the aluminate. This is your answer. Next question, the coordination number of cobalt in. Then what is the coordination number of cobalt? 6. So this is the 6. This is the 6 as the coordination number. So this is the coordination number 6. Octahedral complex. This is octahedral complex. How to calculate the coordination number? Just by number of monodentate ligand directly and 2 into bidentate ligand. If there is a bidentate ligand, multiply by 2, and if there is monodentate ligand, just the number of monodentate ligand is the coordination number, and if there is a bidentate ligand, then multiply by 2. Identify the ion in which the effective atomic number of central atom mine is 35. 35 चाहिए, ठीक है, 35. So zinc, तो effective atomic number. So zinc has the atomic number 30. Get it? 30, and this is a, that's a, okay, 30. So this is a 28. 28 plus zinc na. Zinc has the atomic number 30. What is the oxidation state of zinc? +2. So this is 28. 28 plus 8. 28 plus 8. This is the 36. गेट इट. सो ह्या कॉम्प्लेक्स मध्ये किती असेल हा 36 असेल. Fe ॲज अ 26. ठीक आहे 26 and then oxidation state plus 3, so 23. So this is 23 plus ligand donation how much 612. Yes, this is your answer. Option number C is correct. Get it? Then Fe has a how much, that's electrons. Fe has a 26. What is the oxidation state of Fe? Plus 3. So he loses the 3 electrons. What is the left behind as a 23? And ligand donate the how many electron? 6 into 2, that's a 12. So 23 plus 12 how much? 35. So 35 is the answer. Fe how much? Fe 26. And what is the oxidation state? Plus 2 na Fe. So cyanide minus 6 है, minus 4 मुझे plus 2 है. So this is 24. 24 plus 12 is equal to 36. Get it? Then cobalt. Cobalt atomic number 27. So he loses the how many electron? That's a 3. So 27 minus 3 how much? 24. And ligand donates the electron 12. 6 into 2. Okay, 2. That's a 12. So this is value came as a 36. Get it? So option number C is correct. Question number 10. Get it everyone? तो क्वेश्चन नंबर 10 है इफेक्टिव्ह ॲटॉमिक नंबर आहे. इफेक्टिव्ह ॲटॉमिक नंबर व्हेरी इझी आहे. मेटलकडे इलेक्ट्रॉन किती आहे आणि लिगँडचे इलेक्ट्रॉन किती डोनेट करतात त्यांची ऍडिशन करा, इफेक्टिव्ह ॲटॉमिक नंबर मिळेल डायरेक्टली. गेट इट? यासाठी फॉर्म्युला आहे x मायनस वाय प्लस झेड. गेट इट इवन? तर दिस इज व्हेरी व्हेरी इम्पॉर्टंट. देन तर यामध्ये जो मेटल आहे मेटलचे इलेक्ट्रॉन काउंट करा, त्यांनी ओके मायनस केलेली ऑक्सिडेशन स्टेट ती वजा करा आणि नंतर लिगँडचे इलेक्ट्रॉन त्यामध्ये ऍड करा. गेट इट? will give the effective atomic number. The ligand triethyl नाही हा नका करू आपण. ठीक आहे, हे क्वेश्चन्स दॅट्स डायथिलीन ट्रामाइन. ठीक आहे, हे क्वेश्चन्स 18 चे. गेट इट? जुलै 18 चे क्वेश्चन्स आहे. ट्राइन डाइन टेट्राइन. गेट इट? असे क्वेश्चन्स आहे. इफेक्टिव्ह ॲटॉमिक नंबर हा क्वेश्चन घ्या. नंबर 7. Number 7. The effective atomic number rule is used to find out the effective atomic number rule is used to find out the geometry of the complex, number of possible ligand around the metal ion in a complex, and stability of the complex. So this is the number of possible ligand around the metal ion in complex. Number of possible ligands around metal ion in complex. This is very important. Get it one? तो डी नंबर. आणि हे लिगँड इथे ओके डायथिलीन ना, डायथिलीन ओके ट्रामाइन. ठीक आहे, डाइन म्हणतात त्याला, डाइन ट्राइन टेट्राइन. गेट इट? नेक्स्ट क्वेश्चन is cisplatin compound is used in the treatment of the cancer. Anti-cancer drug na, this is the anti-cancer drug. Cisplatin compound is used in the treatment of the cancer. Anti-cancer drug. Then what is the structure? That's PT NH3 twice Cl2. PT NH3 twice Cl2. So this is the anti-cancer drug, cisplatin. Okay, what is effective atomic number? FeZ 26, FeCN6. ठीक है, तो Fe has the atomic number 26. What is oxidation state? Plus 2. So this is the 24. 24 plus 12, that's the 36. So this is your answer, 36. Get it? Effective atomic number 36. Next is which of the following complexes will use the white precipitate on treatment of the solution with barium nitrate? Get it? Barium nitrate. So barium nitrate, this is the BaNO3. He formed the PPT with the barium, that's a sulfate, barium sulfate. So this is your answer actually. Cr, कारण हा सल्फेट है ना, सल्फेट. तो this is sulfate plus Ba2 plus. And yes, we'll use the BaSO4, barium sulfate, white PPT. This is white precipitate. Get it? White precipitate. So this is in the ionization sphere. So option C is the correct. More salt is what is the formula of the more salt? Is the ferrous ammonium sulfate. Ferrous ammonium sulfate is a more salt. It is double salt actually. Ferrous ammonium sulfate, it is a double salt. It is a double salt. FeSO4, ammonium sulfate and water molecules. Next question, IUPAC name of the K4FeCN6 is. K4FeCN6 is. Then, so there is written as only one as a correct name. So this is the FeCN6. What is the oxidation state of the Fe? Is the +2. +2. So this is your correct action. Potassium hexacyanoferrate. Potassium hexacyanoferrate. This is written as the 2 oxidation state. The complex ion COH2O5ONO and the COH2O5NO2 are called. So these are the ONO and the NO2. ONO, NO2 are the linkage isomer. These are the linkage isomers. Get it? Linkage isomer only because of the cyanide, isocyanide. Next is the that's SCN. Next is the NCS. Next is the NO2, and that's ONO. ONO. Get it? So these are the ambident ligand. Only ambident ligand is present, then such a type of linkage isomer will be shown. Get it? So this is very easy questions. Next, as the theoretical questions, the theoretical questions मध्ये हे MCQ चे questions. They now start the one by one. On the basis of VBT, valence bond theory, explain the nature of bonding in NiCl4 2- complex ion. जुलैचा क्वेश्चन आहे 23 मध्ये. ठीक आहे, याच्यामध्ये VBT नोट करायचं. व्हॅलन्स बॉन्ड थेरी, त्याचे टाइप ऑफ नेचर ऑफ बॉन्डिंग, हायब्रिडायझेशन. गेट इट? टाइप ऑफ बॉन्डिंग, हायब्रिडायझेशन. तुमच्या टेक्स्ट मध्ये नियरली 5 ते 6 एक्झाम्पल आहे की त्यांच्यामध्ये हायब्रिडायझेशन जिओमेट्री आहे. गेट इट? तेवढेच करायचे तुम्ही. ठीक आहे, मी तुम्हाला नोट्स थ्रू शो करेन. ठीक आहे. नेक्स्ट ॲज अ yes, give the cis and trans isomer. July 2023 चा क्वेश्चन आहे. March 2023. Give the cis and trans isomer of the CONH3,4Cl2 1+. ठीक आहे, हे पण मी तुम्हाला ड्रॉ करून दाखवेल. CONH3,4Cl2. Get it? Cis and trans isomer. Just draw the cis and trans isomer. Get it? नंतर डायस्टिरियोमर्स. डायस्टिरियोमर्स म्हणजे जिओमेट्रिक. हा, दिस इज डिफाइन विचारलं ना, जिओमेट्रिक. डायस्टिरियोमर्स म्हणजे जिओमेट्रिक आइसोमर. जिओमेट्रिक मतलब सिस एंड ट्रांस. गेट इट? एक्सप्लेन द फॉर्मेशन ऑफ COF6 3- कॉम्प्लेक्स विथ रिस्पेक्ट टू हाइब्रिडाइजेशन, मैग्नेटिक प्रॉपर्टीज, इनर आउटर मैग्नेटिक कॉम्प्लेक्सेस एंड जिओमेट्री. गेट इट? त्यांची जिओमेट्री काय असणार? जिओमेट्री ऑक्टाहेड्रल आहे. ऑक्टाहेड्रल. Then that's inner and outer orbital complex. So this is the outer orbital complex because fluorine is a weak field ligand. Outer orbital complex because fluorine is weak field ligand. And hybridization is the sp3d2. Hybridization sp3d2. Magnetic property we have to discuss here. Write the name of the platinum complex. Question 3 marks से हाँ, March 2023 सा. Get it? Then next is write the name of platinum complex used in treatment of cancer. Used in treatment of cancer, platinum complex. Write the name of the complex. So it is the cisplatin. Cisplatin. Get it? So it is the PT, NH3 twice Cl2. Get it? Name the complex. Platinum complex, cisplatin. Actually स्ट्रक्चर ड्रॉ करा. स्ट्रक्चर साठी 1 मार्क असेल. एक्सप्लेन होमोलेप्टिक अँड हेट्रोलेप्टिक कॉम्प्लेक्सेस विथ एक्झाम्पल्स. व्हेरी इझी. होमोलेप्टिक म्हणजे सेम टाइप ऑफ लिगँड्स. हेट्रोलेप्टिक म्हणजे डिफरंट टाइप ऑफ लिगँड्स. जुलै 22 चा क्वेश्चन 2 मार्क्सचा. गेट इट? नेक्स्ट एज एक्सप्लेन लिंकेज आइसोमेरिझम कॉम्प्लेक्स विथ 1 एक्झाम्पल. लिंकेज आइसोमेरिझम जुलै 22 चा क्वेश्चन हा. लिंकेज आइसोमेरिझम. लिंकेज म्हणजे कोणते, ॲम्बिडंट न्यूक्लिओफाइल. सो दिस इज शोन बाय द ॲम्बिडंट टाइप ऑफ न्यूक्लिओफाइल्स. ज्यांच्यामध्ये ॲम्बिडंट न्यूक्लिओफाइल आहे, तो ओनली दोज ॲम्बिडंट न्यूक्लिओफाइल शोज द लिंकेज आयसोमेरिझम. Ambident nucleophile shows the linkage type of isomerism. Next, four postulates of the Werner theory of the coordination complexes. Four postulates. Write the four postulates. July 22, July 20 is the question. 2 marks. Very easy question. Four postulates of Werner theory of coordination complexes. Next is the calculate effective atomic number. Effective atomic number cobalt. CONH3 6 3 okay 3 plus. So this is the cobalt 27. So what is the oxidation state, plus 3. Oxidation state किती cobalt ची, plus 3. So 27 minus 3 24 ना, ठीक है 24 and plus 12. So how much, this is, that's a 36. So this is 36. Get it? Next is a explain the monodentate and ambidentate ligand. Monodentate ligand, ambidentate ligand with one example. So this is a question from March 2022. Monodentate contains the only one donor atoms and ambidentate contains the either of the two donor atoms. And just one examples. So examples note करू शकता आपण. Examples मध्ये ambidentate मध्ये so many examples. This is the cyanide, नंतर isocyanide. Next is the NO2. ONO2, ONO, NCS, नंतर CNS, ठीक है, म्हणजे SCNS. Next, write the name of isomerism in the following complexes. March 2020 चा क्वेश्चन आहे. Name of the type of isomerism, CuNH3, Cu, get it? So this is the type of the coordination isomerism. Note करा, coordination isomers, coordination isomers, coordination isomers. So this is type of coordination isomers because the inter-exchange of the ligand between the coordination, okay, that's a ionic, that's a cationic and the anionic sphere. Get it? Explain cationic and anionic and neutral spheres complexes with example. So at least you should be able to write the examples here. This is very important. With examples ना, एक example note करता आलं पाहिजे आपल्याला. At least you should be able to write the one example. Cationic म्हणजे complex carries the one, okay, positive charge, anionic negative charge, neutral sphere complexes. Get it? March 2020 चा question, 3 marks साठी. Write the UPSC name of the FeCO5 complex. FeCO5 complex, pentacarbonyl. So it is written as a pentacarbonyl iron आणि ब्रॅकेट मध्ये काय लिहायचे, 0 बस. दिस आणि अंडरलाइन करा, pentacarbonyl iron 0, pentacarbonyl iron 0. Get it? Oxidation state 0 असणार आहे, कारण हे कार्बोनिल कसे आहेत, that's a neutral complex, that's a neutral ligand आहे. So this is the neutral complex. Next, write the two applications of the coordinate compounds. दोन application. cisplatin बद्दल आपण. cisplatin आहे, अँटी कॅन्सर ड्रग आहे. आणि त्याच्यानंतर तुम्ही हे एक नोट करू शकता EDTA बद्दल. EDTA यूज as a hardness of water, estimate the hardness of water as well as lead poisoning. Get it? Lead poisoning, hardness of water, electroplating बद्दल येऊ शकता, gold plating, silver plating. त्यासाठी तो कॉम्प्लेक्स नोट करा, K potassium Au and then Cn twice. Get it? Gold plating, silver plating. आणि नंतर magnesium present in the chlorophyll, iron present in hemoglobin. Next is the with example difference between double salt and the coordinate compounds. So this is with example, more salt, carnallite. Get it? Difference लिहायचं तुम्हाला. Difference म्हणजे at least 2 point लिहायचे. The double salt dissociate completely and coordinate complex, that's the compounds complex dissociate at least one complex ion. बस एवढं. आणि examples, double salt चे 2 example आहे. मोर सॉल्ट आणि कार्नलाइट, त्यापैकी एक कोणतं पण नोट करू शकता. मोर सॉल्ट अँड कार्नलाइट विथ फॉर्म्युला. गेट इट. सो दिस इज व्हेरी इम्पॉर्टंट क्वेश्चन, 2 मार्क्स क्वेश्चन. डबल सॉल्ट आणि कोऑर्डिनेट कंपाऊंड्स. व्हॉट आर बायडेंटेंट लिगॅंड? बायडेंटेंट लिगॅंड म्हणजे इट हॅज अ 2 डोनर आयटम्स. तर व्हॉट आर द बायडेंटेंट लिगॅंड? EN म्हणजे इथिलीन डामाइन आणि अजून एक कोण आहे? ऑक्झॅलेटो. ऑक्झॅलेटो OX. 2 एक्झाम्पल, गिव्ह 1 एक्झाम्पल. इथिलीन डामाइन, it has a 2 donor atoms. Get it? And then oxalato म्हणजे that's a C2O4 2 minus. Get it? C2O4 2 minus oxalato. So it is a bidentate ligand. At least 1 example note करू शकता तुम्ही. So this is the, okay, that's a 3 marks question. Definition 1 mark, bidentate ligand definition 1 mark, and these 2 example written as 1 marks. Identify the, explain the formation of the COF6 ion on the basis of VBT, valence bond theory, COF6. And that's identify whether the ligand is weak field or strong field. So हे जे identify, okay, ligand काय? Ligand हा weak field आहे. So this is weak field. Strong field नाही हा. This is not a strong field. Fluorine is a weak field ligand. Get it? आणि then त्याचं, okay, bonding explain करायचं, hybridization VBT. ठीक आहे, मी तुम्हाला एक्झाम्पल शो करेन, तिथून तुम्ही नोट करू शकता. Define ionization isomers in coordination compounds with suitable example. Ionization isomers म्हणजे काय? So these are the, that's on ionization then to form the different ions. So this is ionization isomers. So simple. July 20 चा क्वेश्चन आहे, 2 मार्क्स साठी क्वेश्चन आहे. Calculate the effective atomic number of copper in CuNH3 2+. Get it? Copper 29 आहे. So this is what is the oxidation state of the copper? Copper in the +2. So this is the remain as the 27. Get it? So this is the 29. 29 minus how much? 2 and plus 8. So how much? This is the 27. 27 plus 8. This is 35. So this is 35 effective atomic number. Effective atomic number as a 35. Next as a explain the linkage isomerism. Linkage isomerism. So this is the ambidentate ligand. जे ambidentate ligand असतात त्यांच्यामध्ये काय असतं? लिंकेज आयसोमेरिझम असणार. Get it? So this is linkage isomerism. Either of the 2 donor atoms, whether the cyanide or isocyanide or nitro or ONO, nitrito or NCS or SCN. Get it? In this way. So this is shown by the ambidentate ligand. Write the IUPAC name of the PTEN twice Cl2 2+ complex ion. So this is the diethylamine. Get it? Diethyl म्हणजे bis लिहायचे. This is bis. Bis-ethylene diamine. Bis-ethylene diamine and dichloro. Starting ला dichloro, bis-ethylene diamine, platinum आणि how much oxygen state? +4. Get it? Platinum oxygen state काय असणार? +4. What is the dichloro? Bis-ethylene diamine, bis-ethylene diamine, platinum आणि 4th आणि underline it. Get it? Underline करा. We'll get the 1 marks. Okay, calculate the effective atomic number of the copper. Same question I think, repeated. Copper 29 CuNH3 2+. What is oxygen state? Copper +2. So this is the 29 minus how much? +2 oxygen state and plus that's a 4 8. So this is how much become as a 27 plus 8 is equal to 35. So this is effective atomic number as a 35. Effective atomic number. This is the Z minus X plus Y. Z minus X plus Y. This is the formula. Okay, write the formula of the pentamine chlorocobalt. Pentamine chlorocobalt. So this is the as the cobalt. Pentamine stand for the NH3 5. Pentamine chloro. So this is the chloro. And in bracket sulfate SO4. ठीक है. Then how to, okay, that's oxidation state. How to balance oxidation state? So this is the cobalt. Cobalt has a +3. Cobalt +3. Chlorine -1. Yes. So this is the +2 sulfate. This is your formula. Correct. This is your formula. CONH3 5, CONH3 Cl and sulfate. Get it, everyone? So yes, these are the questions. Next is explain the geometry of the CuNH3 4 2+ on the basis of hybridization. Geometry. So this is the hybridization VBT part. This is the VBT, valence bond theory. Calculate the effective atomic number of CO and zinc in so and so compound. So this is the cobalt. So cobalt has the atomic number 27. So what is the oxidation state? +3. So this is 3. And what is the 12? So this is how much? That's the 24. 24 plus 12. So this is 36. 36. Effective atomic number 36. What is the formula? Z minus X plus Y. Then in this, that's is equal to zinc has the atomic number 30 minus what is the oxidation state of the zinc? This is the +2, so this is 2 plus 8. So 28 plus 8, so this is 36. Effective atomic number. Next is calculate the effective atomic number of the metal in the following complexes. Effective atomic number, that's the K4 FeCN6. So what is the oxidation state of the Fe? +2. So Fe has the 26. 26 minus 2 and plus 12. So this is the 24 plus 12 as the 36. So this is the 36. Next is the CrCO6. Okay, chromium 24. So this is the 24. What is the oxidation state? 0 and plus 6. So this is the 12. So 24 plus 12, how much? That's the 36. So this is your answer, 36. Get it? Okay. Next is the what is effective atomic number? Effective atomic number म्हणजे काय? त्याची डेफिनेशन लिहायची तुम्हाला. Very easy. 1 mark साठी definitions. Just write the definition. Write applications of the coordination compounds in medicine. मेडिसिन मध्ये काय असणार आहे? सिस्प्लॅटिन बद्दल लिहायचे. सिस्प्लॅटिन हा अँटी कॅन्सर ड्रग आहे आणि इलेक्ट्रोप्लेटिंग बद्दल म्हणजे सिस्प्लॅटिनचा कॉम्प्लेक्स लिहायचा. दिस इज द PT Cl2 NH3 किंवा NH3 twice Cl2 लिहू शकता असं. आणि त्याच्यानंतर इलेक्ट्रोप्लेटिंगला गोल्ड अँड सिल्वर प्लेटिंग आहे. सो पोटॅशियम KAu CN twice गोल्ड प्लेटिंग आणि सिल्वर प्लेटिंग साठी काय नोट करायचे? KAg CN twice. So this is complex. State the superiority of the CFT over the VBT. ठीक आहे, आपण ते नोट्स मध्ये पाहू. What is the superiority of CFT over VBT? Next is write the formula of the tetraamino dichloroplatinum chloride. What is the formula? Tetraamine platinum. So written as the platinum. Get it? Platinum. Next the tetraamine. This is the tetraamino. So this is the NH3 and this is the 4. Get it? Tetraamino. Okay, dichloro Cl2 and this is the okay chloride Cl. So what is the oxidation state of the platinum? Platinum plus 2. So this is the Cl2 plus 2. Get it? So this is plus 2. So this is I think Cl2. Get it? Cl2. Then the okay how this is the how many? Yes, correct. This is Cl2. Amino instead of amino written as amine. AMMINE. INE अमाइन, गेट इट, अमिनो अमाइन. ठीक आहे, CBSE मधलं आहे. मी एक क्वेश्चन दिलता पहा तुम्हाला, हा पण CBSE NCERT मधलाच क्वेश्चन, तो लिगँडचा माहिती ना, इथिलीन डामाइन डाय ट्राय टेट्रा बीस, त्यामुळे गेट इट, हा पण क्वेश्चन तिकडचाच. पण हे विचारलेत पहा इकडे पण क्वेश्चन. राईट द फॉर्म्युला ऑफ द कॉम्प्लेक्स कॉपर हेक्सासायनोफेरेट, कॉपर टू हेक्सासायनोफेरेट कॉम्प्लेक्स है. राइट द फॉर्म्युला ऑफ द कॉम्प्लेक्स कॉपर टू हेक्सासायनोफेरेट, कॉपर में Cu आणि हेक्सासायनो, गेट इट, हेक्सासायनो, दिस इज Fe, हेक्सासायनो CN6, get it, hexacyanoferrate. Then how to balance the oxidation state? Okay, that's copper as a +2, so this is +2, and cyanide how much, +4, so this is the Cu2, get it, this is CO2, Cu2 FeCN6, Cu2 FeCN6, this is your formula, Cu2 FeCN6. Next is write the formula of the following compounds. Write the formula of the following complex. Sodium hexanitro, sodium, so this is Na, hexanitro, N cobaltate, so this is cobalt, hexanitro N, so this is the NO2, hexa 6. Then how to balance the cobalt oxidation state? So this is nitro as a -6, so this is the Na3, get it, so this is the Na3CO NO2 6. N stand for nitrogen through bonding, nitrogen. O stand for oxygen through bonding. Next is the tetra echo dichlorochromium, chromium stand for Cr, get it, Cr, tetra echo, so this is the H2O4, dichloroCl2, outside bracket Cl. Then how to balance the oxidation state? Okay, chromium as a Cl2, and so this is Cl, so chromium plus Cl. Yes, this is correct. Correct is Cr H2O4 Cl2 Cl. Next is the potassium tetracyano, potassium stand for K, tetracyano orate stand for Au म्हणजे orate gold, tetracyano CN6, and then oxidation state, so Au as a +3, so this is the K3, this is the K3 Au CN6. So yes, this is your formula. Next, calculate the magnetic moment of Fe2 plus ion. Actually हा क्वेश्चन याच्यामधला डी ब्लॉक मधला क्वेश्चन आहे, पण ठीक आहे, हा Fe2 प्लस आहे ना, सो Fe2 प्लस ॲज अ 3D हाऊ मच, 3D6, Fe2 plus 3D6, so 4 unpaired electrons, so mu is equal to under root of the n plus 2 Bohr magneton, get it, so 4 unpaired electrons, 3D6 में 4 unpaired, so mu is equal to under root how much, 4, so 4 plus 2, so how much value, under root as a 4 plus 2 6 to 24, under root 24 value, how much value become as a 4.90 Bohr magneton, get it. So this is a question from the D block actually. Calculate the magnetic moment of Fe2 plus ion. तो Fe2 plus ion ची तुम्हाला calculate करायची आहे magnetic moment. So how to calculate? Under root n plus 2 Bohr magneton, get it. So this is too much easy questions from the coordination compounds. So yes, these are the questions. Next is the ठीक आहे, मी तुम्हाला याचे नोट्स शो करेन, तर सिनॉप्सिस नोट्स एक पहा आपण, गेट इट, आणि तसे अकॉर्डिंग टू काय करा ते सॉल्व करा सर्व ऑल. ओके, गेट इट. नाउ स्टार्ट द वन बाय वन. तो स्टार्टिंग मध्ये दॅट्स वर्नर थेरीज आहे. वर्नर थेरीज व्हेरी इम्पॉर्टंट आहे. वर्नर थेरी ऑफ द कोऑर्डिनेशन कंपाउंड्स. Get it? Werner theory of coordination compounds. The basic postulates of the Werner theory of the coordination compound. That's a two type of valency, primary valency and secondary valency. Every metal tend to satisfy both its primary secondary. Metal has a fixed number of secondary valency. Secondary valency always directed by the space. Get it? नोट करू शकता. Limitations आहे, पण limitations काय तुम्हाला विचारणार नाही. नंतर BBT, CFT. Get it? याच्यानंतर सायलेंट फीचर्स तुम्हाला नोट करायला लागतात. फीचर्स, सायलेंट फीचर्स ऑफ द वर्नर थेरी. प्रायमरी व्हॅलन्सी अनऑक्झिलरी व्हॅलन्सी. ही कॅल्क्युलेट द ऑक्सिडेशन स्टेट. सेकंडरी व्हॅलन्सी ऑक्सिलरी व्हॅलन्सी म्हणतात त्याला. नॉन आयनायझेबल व्हॅलन्सी. इट इज डिटरमाइन द कोऑर्डिनेशन नंबर. गेट इट? अँड सो देर इज अ टू स्पियर्स. एक इनर स्पियर असणार आहे आणि आउटर स्पियर कोऑर्डिनेशन अँड द आयनायझेशन स्पियर्स. गेट इट? तर ओके, दीज आर द पॉइंट्स. बस बाकी काय नाही यामध्ये. एवढे जर लिहिले तरी ठीक आहे, सफिशियंट आहे. So this is its ionization sphere, coordination sphere. Get it? ठीक है, in this way. Experimental observations. नहीं हे नका नोट करो आपण. ठीक है. yes, this is CH6 ammonia molecules. Ligands म्हणजे काय? What are the ligands? The molecular ions which are donated to the metal atom or ions in coordination compounds. Get it? Molecules or ions which are coordinated to the metal atom or ions known as the ligands or donor atoms. He donate the that's electron pair. Generally हे जे negative ions असतात, negative ions ची so many list आहे. Cyanide, nitride, hydroxide, nitrate, chloride, bromide. Get it? So many oxides also there. Next is the neutral. तो जे न्यूट्रल मॉलिक्यूल्स असतात, कार्बन मोनॉक्साइड, वॉटर आहे, हायड्रॉक्सिल अमाइन आहे, मिथिल अमाइन पण वापरतात. गेट इट? दिस इज ऑल्सो यूज ॲज अ लिगँड्स. आणि पॉझिटिव्ह मध्ये नायट्रोसियल एक वापरतात, हायड्रोजनियम वापरतात. ठीक आहे, पण नो नीड टू रिमेंबर हिअर. ते सीईटी ला विचारतो तुम्हाला. नंतर लिगँड्स, क्लासिफिकेशन ऑफ लिगँड्स मध्ये दीज आर द monodentate, unidentate ligand, ligand which has the only one donor atoms. बस एवढं इम्पॉर्टंट आहे. only one donor atoms. एक्झाम्पल लक्षात ठेवा. these are the examples. only one donor atoms. and it carries a नंतर पॉलिडेंटेट किंवा मल्टीडेंटेट मध्ये it has a that's a two or more donor atoms. Get it? And again it is further classified as a bidentate. So bidentate ligands मध्ये इथिलीन डायमाइन, ऑक्झॅलेटो आणि DMG म्हणतात त्याला, डायमिथिल ग्लायकॉक्समेटो, बायडेंटेट. आणि हे ट्रायचे एक्झाम्पल्स आहे. ट्राय म्हणजे काय? डायथिलीन ट्रायमाइन, म्हणजे कोणते? ट्रायडेंटेट. गेट इट? ट्रायडेंटेट. डायथिलीन ट्रायमाइन, डाइन म्हणतात त्याला. डाइन हा ट्रायडेंटेट आहे. दिस इज ट्रायडेंटेट. नेक्स्ट इज द टेट्राडेंटेट मध्ये ट्रायथिलीन टेट्रामाइन, ट्राइन. दिस इज ट्राइन ऑल्सो देअर. गेट इट? आणि हेक्साडेंटेट मध्ये एकच एक्झाम्पल आहे, EDTA इज अ हेक्साडेंटेट. गेट इट? सो दिस इज द लिगँड्स. ते जे लिगँड्स यांचे स्ट्रक्चर्स असे इन दिस वे. मोनोडेंटेट लिगँड मध्ये दीज आर द water aqua. He donate the electron in this way. This is the direction to which the electron donated. Ammonia, amine. Okay, ammonia. नंतर next is the bidentate ligand. Bidentate में ethylene diamine है, EN. This is called EN. Oxalato OX. DMG dimethyl glycoxamate होता है. DMG. This is the structure of the DMG. Dimethyl glycoxamate. This is the bidentate ligand actually. Bidentate ligand. Get it? This is bidentate ligand. Next is the tridentate ligand. So this is tridentate ligand. That's a dine. Dine stand for the diethylene triamine. This is the diene. Diene is a tridentate ligand. Get it here? And next is the tetradentate ligands. Tetradentate ligands are the triethylene tetramine. This is the triethylene tetramine. This is the triene. Hexadentate ligand. Hexadentate ligands are EDTA. So this is the actual structure of the EDTA. EDTA, ethylene diamine tetraacetoacetate. Get it? So this is the structure of the EDTA. EDTA. So he donates the electron in this way: oxygen through 4a, nitrogen through 2a. Get it? So this is the structure of the EDTA, ethylene diamine tetraacetate. Get it? EDTA. EDTA is a hexadentate ligand. Next is a coordination number. What is the coordination number? So directly bonded to the ligands and then donate the electrons. Get it? So this is so simple as the coordination number. Coordination numbers of metal influence several factors. Get it? Charge as well as ligands. And then check examples. Okay. Next is the complexes classification से types of the coordination compounds, complexes, type of coordination compounds, complexes. Homoleptic, it contains attached one kind of donor atoms, only one type of donor atoms. Get it? And so it is more than one kind of donor atoms. Okay, type of donor atoms. So this is the only one type of donor atoms. Heteroleptic, this is homoleptic, this is heteroleptic. At least you should able to write the any one example. एक example तो note करते आलो पे तुम्हारा. Cationic and anionic. The complex which can complex carries a negative charge, positive charge, negative charge. Get it? होना as a cationic, anionic. At least एक example करा आपण ना. एक example तरी माहित पाहिजे तुम्हाला याच्यावर. So many examples मी note केले दे. But at least you should know the one example. Neutral complex example लक्षात ठेवा. The complex which carries a no charge. Complex which carries a no charge, neutral. Cationic, anionic definition and एक example. At least you should able to write the one example. Next is the double salt. Double salt, which is an additional compound, say dissociate into their constituted ions completely. Dissociate their complete ion completely. More salt म्हणजे FAS म्हणतात त्याला. Ferrous ammonium sulfate. Ferrous ammonium sulfate म्हणजे more salt. More salt म्हणजे ferrous ammonium sulfate will give the Fe2 plus ammonium, get it, and sulfate ion completely. Get it even? More salty double salt because aqueous solution of more salt gives the taste of both. Get it? So it gives all this one. More salt. So this is called as the double salt. Carnallite, अजून एक example आहे carnallite. ते करून ठेवा आपण carnallite. Get it? नंतर coordination compounds. Coordination compound, those molecules which do not retain their identity. So it forms the contains at least one complex ion. So this is no further dissociation. So this is called as a coordination compounds. So ferrocyanate ion is a complex ion and retain their identity in aqueous solution because does not dissociate further. Does not dissociate further to use the CO2 plus or cyanide minus. Hence does not use the taste of Fe2 plus and cyanide minus ion. Get it? So this is the FeSO4, then to use the complex potassium ferrocyanide. Next is the charge number of complex number. What is the charge number? The net charge carried by the complex ion is known as the charge number. So it is the algebraic sum of the charges carried by the central metal ion and ligand attached to it. Get it? त्यांचे ligand से त्यांचे किती charge number. Oxidation number, all the ligands are removed along the metal ion pair share with the metal ion. Then charge on the metal ion known as the oxidation number also there. Get it? But it is the oxidation state of the metal ions. Next is the coordination and the characteristic of complex ion. Okay, this is very important. That's a chelate complex is more stable than complex with the similar but the monochelated. So the Zn twice is more stable than because of that's a chelate complex because of the En, that's ethylene diamine. So he make as a ring. This is stable. So this is stable. Get it? Next as the effective atomic number. So what is the effective atomic number? Effective atomic number is the total number of electrons around the central metal ion present in the complex. Is the total number of electrons around the central metal ion present in a complex. So effective atomic number is calculated by using the formula Z minus X plus Y. Get it? So this is the effective atomic number. What is the Z atomic number of metal? Number of electron lost during the formation of the metal ion from the atom and number of electrons. Get it? So this is number of electron donated by the ligands. Y. So this is IMP formula. Please note kara. This is very important formula. Next is the effective atomic number rule. A metal ion continue to accept the electron pair from the ligand till the total number electron present in around the metal ion in the complex becomes equal to the atomic number of the next rare gas atom. So this is the rule. The statement IMP kara apan. This is the important statement. Applications of effective atomic number. Effective atomic number rule is useful to find out number of the possible ligands around the metal ion because the ligands are added to the metal ion until the number of electrons around the metal ion reaches its effective atomic number. So this is also important. What is the application of effective atomic number? And if that's a few exception for the effective atomic number. So these are the complexes. So he complexes आहे त्यांच्यामध्ये हे number not a 36. This is not OB. Effective atomic number is not OB. Get it? तो हा एक टेबल लक्षात ठेवा आपण Z plus X minus Y. Effective atomic number म्हणजे काय? Z minus X plus Y. हा एक टेबल आपण लक्षात ठेवा. This is very important table. Complex. And effective atomic number that's Z minus X plus Y. Completed. Okay. Examples IMP लक्षात द्या. Examples important आहे. Example solve करा आपण. Next is IUPAC nomenclature. IUPAC name of the mononuclear coordination complex. The name of cation name first followed by the name of the anion. त्याचे काही rules आहे. Rules important आहे. Naming the complex. Then the oxidation state of metal is written in the meshed ion in the Roman number parenthesis. The complex anion is named by writing the ligand followed by the name of the suffix AT and non-ionic complex named by the one letter. Alphabetical order follow करा आपण. Get it? Alphabetical order. That's the two different name of ligands. So it is the name of anionic ligand end with the O. Those with the cationic ligands with the aqua, water, amine, double amine लिहायचं आहे. Next आणि carbonyl for carbon, nitrosyl for YNO stand for nitrosyl and these are written in the bracket. Prefix मध्ये di असेल, tri असेल, tetra, penta, you should be able to note it. More identical ligands say, get it? And chelate ligands have the complex name having prefix as such as the bis, tris, tetrakis. So bis is the 2, tri 3, tetrakis is the 4. Order of naming that's a positive ion असेल. The positive ion neutral ligand and then negative ion, and neutral ligand negative ligand and then metal ion. Get it? Positive ion पहिला, neutral ligand and नंतर negative ion. कोऑर्डिनेशन स्पियर लिहिताना ही ऑर्डर फॉलो करायची. पहिल्यांदा लिहिताना पॉझिटिव्ह आयन लिहायचा, न्यूट्रल लिगँड आणि निगेटिव्ह आयन, किंवा न्यूट्रल लिगँड आणि देन निगेटिव्ह लिगँड आणि देन मेटल आयन असं लिहायचं. So these are the correct way to write the formula. Neutral ligand, negative ligand and then metal ion and if there is a positive ion, so written as a positive ion first, then neutral, then negative, in this way. Get it? So this is a negative ligand first, okay, negative neutral ligand first, then negative ligand, and then last as a metal ion. Formula लिहिता ना, this is for the formula. त्याच्यानंतर नेम ऑफ द लिगँड्स, त्यांची नावं लक्षात ठेवा. आपण ब्रोमाइड असेल तर ब्रोमो, क्लोराइड क्लोरो, सायनाइड सायनो, हायड्रॉक्साइड हायड्रॉक्सो, ऑक्साइडचा ऑक्झो नोट करतात. ऑक्साइड ऑक्झो, कार्बोनेटो कार्बोनेटो, कार्बोनेट कार्बोनेटो, नायट्राइट नायट्रो, ऑक्झलेट ऑक्झलेटो, अमाइन, अमाइनला अमीन लिहितात, अमाइनला अमोनिया अमीन. गेट इट? कार्बोनिल, कार्बन मोनॉक्साइड कार्बोनिल, वॉटर एक्वो एक्वो, नंतर इथिलीन डामाइन, इथिलीन इथिलीन अमाइन लिहितात, इथिलीन अमाइन. नायट्रोजन ऑक्साइड्स, नायट्रोसिल नायट्रोसिल, इथिलीन डामाइन्स नोट करता. गेट इट? आणि समजा कॉम्प्लेक्स निगेटिव्ह असेल, नेम ऑफ द अनॉनिक कॉम्प्लेक्सेस, तर अनॉनिक कॉम्प्लेक्स कसे नोट करायचे? अनॉनिक कॉम्प्लेक्स इन दिस वे. ॲल्युमिनियम असेल तर ॲल्युमिनेट लिहायचं, क्रोमियम असेल तर क्रोमेट, कोबाल्ट कोबाल्टेट, कॉपर क्युप्रेट, गोल्ड ऑरेट, गोल्ड म्हणजे एयू 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 गोल्ड, आयर्न फेरेट, लीड प्लंबेट, लीड बद्दल प्लंबेट लिहायचं, प्लंबेट म्हणजे लीड. मॅग्नीजला मॅग्नेट, एमएन. मॉलिब्डेनमला मॉलिब्डेनेट, निकेल निकेलेट, सिल्वर अर्जिनेट, सिल्वर म्हणजे एजी. आणि टीन म्हणजे एसएन, टीन असेल तर स्टॅनेट. आणि झिंक असेल तर लिहायचं झिंकेट. तर हे अनॉनिक कॉम्प्लेक्स बद्दल नोट करायचं. गेट इट? दीज आर फॉर द अनॉनिक कॉम्प्लेक्सेस. आता इथे काही कॉम्प्लेक्सेस आहे, त्यांचे आयुपीएससी नेम आणि कॉमन नेम्स इथे मी नोट केलं. मी दॅट्स अ फॉर्म्युला अँड द नेम. गेट इट? दिस इज व्हेरी इम्पॉर्टंट टेबल. तर प्लीज हा टेबल लक्षात ठेवा. आपण टेबल IMP हा. गेट इट? टेबल चेक करा बरं, विजिबल आहे का टेबल? येस, दिस इज विजिबल. तर एवढेच एक्झाम्पल करा. दिस इज व्हेरी व्हेरी इम्पॉर्टंट. हा, तुम्हाला एक्झाम मध्ये हेच क्वेश्चन येतील. ठीक आहे, टेबल विजिबल आहे का? येस, टेबल विजिबल आहे. हे एक्झाम्पल करून ठेवा आपण. तर हे नाव आहे कॉम्प्लेक्स आणि त्यांचे नेम आणि देन फॉर्म्युला. गेट इट? ॲटलिस्ट यू शुड एबल टू राईट द नेम फॉर्म्युला. क्लिअर आहे? नोट करा सर्वांनी. दिस इज व्हेरी इम्पॉर्टंट. एक्झाम्पल्स नोट करून ठेवाय सर्व. ऑल दीज आर एक्झाम्पल्स. एक तर तुम्हाला असं विचारते की फॉर्म्युला दिला जाईल, नेम विचारतील, किंवा नेम दिला जाईल, फॉर्म्युला वी हॅव टू कॅल्क्युलेट इट. सो दिस इज द फॉर्म्युला वी हॅव टू डिटरमाइन. गेट इट? फॉर्म्युला वी हॅव टू रिटर्न हिअर, नेम हिअर, रिटर्न हिअर, फॉर्म्युला. ओके, दिस इज व्हेरी व्हेरी इम्पॉर्टंट. तर प्लीज हे नोट करा आपण आणि कम्प्लीट करा. गेट इट? सो दिस इज द नेम. Formula is given, name we have to calculate, determine, and then if the name is given, then write the formula. Okay, clear है? ठीक है. Next is next question. Draw the structure of the following complex ion. ठीक है, draw the structures. Draw the structure of the following complex ion. यांचे तुम्हाला स्ट्रक्चर ड्रॉइंग विचारतात, पण ठीक आहे, खाली आपण व्हीबीटी पाहणार आहे. व्हीबीटी, व्हॅलन्स बॉन्ड थेरी. ठीक आहे, आयसोमेरिझमचा एक टाइप आहे. आयसोमेरिझम नंतर व्हीबीटी. Okay, now start the isomerism. So the isomerism in the coordination complexes. So these are the two type of isomerism. तर एका टाइप मध्ये स्ट्रक्चर आयसोमेरिझम आहे. नंबर 1 स्ट्रक्चर आयसोमेरिझम, आणि नंतर आहे दॅट्स अ स्टिरिओ आयसोमेरिझम. स्टिरिओ म्हणजे काय? सेम लिंक आहे अमंग द कॉन्स्टिट्यूएंट ॲटम, पण अरेंजमेंट ऑफ द ॲटम्स इन स्पेस आर डिफरंट. स्पेसमध्ये अरेंजमेंट डिफरंट आहे, पण लिंकेज सेम आहे. आणि त्याच्यामध्ये येतात ज्योमेट्रिक. ज्योमेट्रिक म्हणजे डायस्टिरिओमर्स. डायस्टिरिओमर्स म्हणजे ज्योमेट्रिक. geometric mean diastereomer. These are the non-superimposable possible in the heteroleptic complexes. Cis and trans type of arrangement, and cis isomerism observed in square planar octahedral 4 coordination complex do not show the cis and trans isomers. Get it? So this is for geometric. आता geometric मध्ये पुन्हा येतात दोन टाइप. Get it? तर 4 coordination sphere complex and 6 coordination sphere complex. तर जनरली जे स्क्वेअर प्लेट म्हणजे टेट्राहेड्रल तर शो करत नाही, कारण टेट्राहेड्रल डू नॉट शो sp3 हायब्रिडायझेशन. पण स्क्वेअर प्लेनर मध्ये असे पाहिजे MA2B2 टाइप किंवा MA2BC टाइप हायब्रिडायझेशन DSP2 आहे. गेट इट? हायब्रिडायझेशन DSP2 या टाइपचे पाहिजे. दिस इज द टाइप ऑफ द स्क्वेअर प्लेनर. आणि 6 कोऑर्डिनेशन मध्ये असे पाहिजे MA4B2, MA4BC, MAA. A is a bidentate ligand, म्हणजे हायब्रिडायझेशन D2sp3 or sp3 D2 hybridization in this category. Get it? So this is the type of the complexes. आता त्यानंतर ऑप्टिकल आयसोमेरिझम. ऑप्टिकल म्हणजे इनॅन्शिओमर्स. these are the enantiomers or optical isomers. आणि ऑप्टिकल म्हणजे काय? तर these are the non superimposable mirror images of each other. Get it? Non superimposable chiral molecule should be chiral. Enantiomers have the identical properties different in their plane polarized. The enantiomer that rotates the plane polarized is known as the dextro. Clockwise right side म्हणजे कोण असणार? Clockwise. Other that rotate the anti-clockwise known as the Leo. Get it? Leo. And square planar complexes do not show enantiomers because of the mirror plane and axis of symmetry. Mirror plane and axis of symmetry. Then it has the further two types. 4 coordination sphere. 4 coordination component tetrahedral and square planar. Square planar do not show optical isomers. Square planar do not show optical isomers because they have the mirror plane and axis of symmetry. They have the mirror plane and axis of symmetry. And 6 coordination sphere, yes, it shows the optical isomerism. Get it? So this is the one by one. So geometric isomerism in the square planar complexes. The geometric isomerism in square planar complexes मध्ये PT NS3 twice Cl MA2B2 type. So this is the one of the example. Get it? So this is the geometric isomers. Geometric isomer in the square planar complexes. So this is a cis isomer. Cis isomer in the sense that Cl and Cl on the same side, adjacent side. So this is adjacent side as a cis isomer, and this is the opposite side. This is the opposite. So it is trans. Opposite is the trans, adjacent is the cis isomer. Get it? So this is the cisplatin. Then what are the points for the cisplatin? Anti-cancer drug है, physiologically active है, more soluble in water है, polar है with non-polar dipole moment है. Physiologically inactive है, less soluble है, non-polar है with zero dipole moment because the two opposite PTCl and PTNS3, these are the which cancel the each other. Get it even? So this is the cis and trans cisplatin. Next is the type, second type है, that's MA2BC type मध्ये म्हणजे that's a PT and this is a CL. So it is cis isomer. Get it? So this is the CL, it is the opposite. This is adjacent, and this is opposite. If this is adjacent, it is cis. If this is opposite, trans isomer. So you should be able to draw the cis and trans isomer. Get it here? Cis and trans isomer, you should be able to draw it. Next is the geometric isomers in octahedral complexes. Octahedral complexes MA4B2 type. So what is the MA4B2 type? In this way. Get it? So this is the Cl and Cl on the same side. So Cl same side, so it is cis. And Cl and Cl on opposite side, so it is trans. Get it? how it is cis and how it is trans. Get it? Cis and trans. You should be able to draw the structure of the cis and trans isomer. Next example is that's if there is a bidentate ligand. Get it? Bidentate ligand. En. So this is the Cl. This is adjacent. Adjacent. So this is adjacent. So this is the cis isomer. And this Cl and Cl on opposite side. So it is trans. So it is trans. Get it? Draw करू शकता आपण. This is very easy. Other example of this type, I think हे तुम्ही draw करू शकता. Get it? हे draw करा तुम्ही. COEN twice NO3 2 plus C नंतर IR iridium. Get it? C2O4 Cl2 3 minus 2 minus दोन्ही सेमच आहे, पण at least you should be able to draw it. Get it? Next is optical. नाही, geometric अजून एक example आहे. MA4BC type. MA4BC type. So this is the example. MA4BC type. Get it even? So this is a ClBr on same side. So this is cis. This is cis. आणि Cl आणि हा एक Cl आहे. Cl आणि Br. This is trans. So this is trans. Get it? MA4BC type. So this is the MA4BC type. Cis and trans. How to draw the cis and trans isomers? Next example is FeCN twice CN4. FeCN6 Cl4. Get it? So this is that's NH3 NH3. NH3 NH3. So this is the trans. Cis. So this is cis actually. Get it? Cis. Okay. And then NH3 NH3 opposite side, or NH3 NH3 opposite side trans. So this is trans. Get it everyone? NH3 NH3 on same side, this is cis. And if the NH3 NH3 on the opposite side, so it is called as a trans. Get it even? Please check your example, and then at least you should be able to draw it. At least you should be able to draw the isomers. Drawing important है. Drawing तुम्हाला करता आलं पाहिजे. Drawing ला marks आहे. Optical isomer. Optical म्हणजे enantiomers. Optical म्हणजे enantiomers. त्यांची mirror image draw करायच्या. So first draw the mirror image. Get it? CrOx3 3 minus. CrOx3 3 minus. OX म्हणजे oxalate. So draw in this way. Get it? So in this way. So okay, what is this? So this is the D form, this is the L form. One is the D, second is the L. Code as a D and L. There is no as a restriction for L and D, or DL or L and D. But both are not D, both are not L, because this is mirror images. Get it? This is mirror images. So at least you should able to draw it. Get it? Complex समजला सर्वांना? CrOx3 3 minus. So CrOx3 3 minus. Get it? So this is the structure of the optical isomers. So enantiomers. It is called as the enantiomers. Enantiomers म्हणजे काय? So this is the mirror images. Mirror images draw करायचे तुम्हाला. Left right right left. ड्रॉइंग इम्पॉर्टंट आहे, लक्ष द्या. ड्रॉइंग आलंच पाहिजे तुम्हाला. ड्रॉइंग जर का नाही आलं तर मार्क्स मिळणार नाही. तिथे 2 मार्क्स साठी असतं ड्रॉइंग. ऑप्टिकल आयसोमर्स. गेट इट? क्लिअर आहे सर्वांचं? ओके. सिस. ओके. याच्यामध्ये डी आणि एल. डी एल. डी म्हणजे डेक्स्ट्रो, एल म्हणजे लिव्हो. देन इफ यू राईट द डी हियर, राईट द एल ऑन मिरर इमेज. इफ एल then D. Both are not D, both are not L. one D and one L. D stand for dextro, L stand for LU. Next example is En. COEN3 3 plus. COEN. En stand for ethylene diamine. En stand for ethylene diamine. Ethylene diamine 3 plus. Get it? Ethylene diamine 3 plus. So this is the COEN. En ethylene diamine. Get it? And then 3 plus. A mirror image. So this is the written as a mirror in between the mirror. Get it? So this is the D. This is the L. L isomer. D isomer, L isomer. D isomer, L isomer. At least return the D and L isomer. Get it even? D isomer, L isomer. If written the one as a D, second as a L isomer. COEN is 3. Okay, please draw करा. This is very important. The exam मध्ये तुम्हाला direct हेच question येतील. Get it? These are the question for your board exam. D form, L form. Next is a देन आता असे काही एक्झाम्पल्स आहे की त्यांच्यामध्ये सिस्ट दॅट्स ऑक्टाहेड्रो कॉम्प्लेक्सेस एक्झिस्टिंग बोथ जिओमेट्रिक अँड ऑप्टिकल आयसोमर्स. नाउ स्टार्ट द सम ऑफ द ऑक्टाहेड्रो कॉम्प्लेक्सेस. बोथ म्हणजे दोन्ही पण जिओमेट्रिक आणि ऑप्टिकल पण आहे. जिओमेट्रिक ॲज वेल ॲज ऑप्टिक. देन आता जिओमेट्रिक मध्ये दीज आर द ऑप्टिकल आयसोमर्स. तर वन इज द डी, वन इज द एल. गेट इट? सो दिस इज द डी अँड एल. So written PtCl2En twice 2 plus PtCl2En twice 2 plus. So draw the okay, this is the isomer. So this is the type of the to which cis isomer. No? So this is the Cl is the cis है हा. This is cis. Get it? Optically active cis isomer है. पण तो optically active है. This is optically active cis isomer है. म्हणजे हा cis isomer है पण तो optically active है. कारण हा कोणी हा डी आहे, हा एल आहे. गेट इट इन दिस वे. सो रिटर्न ॲज अ ऑप्टिकली ऍक्टिव्ह सिस आयसोमर्स. ऑप्टिकली ऍक्टिव्ह सिस आयसोमर. अँड देन दिस आयसोमर. आता हा जो दुसरा आयसोमर आहे हा ट्रान्स आयसोमर आहे. म्हणजे याचाच आहे PtCl2En टॉईसचाच. पण Cl आणि Cl कसं आहे अपोजिट आहे ना. गेट इट? सो दिस इज ऑप्टिकली इनएक्टिव्ह ट्रान्स आयसोमर आहे. ऑप्टिकली इनएक्टिव ट्रांस आइसोमर है. नेक्स्ट is a draw enantiomers. Question है, this is very important question. Draw enantiomer of cis and trans isomer CrH2O twice OX2, where OX is the C2O4 2 minus. Get it? So what is this? So this is that's water cis isomer है. This is cis isomer. So that's draw the cis isomer first. And optically active cis isomer. Optically active cis isomer. Optically active cis isomer. Geometrical isomers say cis. And these are the mirror images, so it is optical. And next is these are the examples. म्हणजे हे example same आहे. आणि हा जो फॉर्म आहे हा ट्रान्स फॉर्म आहे. ऑप्टिकली इनएक्टिव्ह ट्रान्स आयसोमर. बिकॉज water on opposite side. So this is a plane of symmetry. So there is a plane of symmetry, axis of symmetry, plane of symmetry. So it is optically inactive. Optically inactive because of the plane of symmetry. Get it? Axis of symmetry. नेक्स्ट आहे दॅट्स आयसोमेरिझम मध्ये तो एक पार्ट राहतो. तो कोणता? स्ट्रक्चरल आयसोमेरिझम. ठीक आहे, स्ट्रक्चरल आयसोमेरिझम तो स्टार्टिंगचा पार्ट आहे स्ट्रक्चरचा. स्ट्रक्चरल मध्ये आयोनायझेशन आयसोमर्स. व्हॉट आर द आयोनायझेशन आयसोमर्स? आयन आयन एक्सचेंज आयसोमेरिझम particularly. there is an exchange of ions inside and outside the coordination sphere. Get it? Ionization मध्ये ionization isomers. And therefore this is 2 are the ionization isomers because ions present in solution. This is plus minus 2 plus sulfate 2 minus. Get it? So it formed the test with the barium sulfate, barium chloride, sulfate with barium sulfate, and silver nitrate bromine, then AgBr in this way. Get it? So it forms the ions. Another examples. हे examples note करून ठेवा. This is IMP examples. हे ionization चे examples आहे. Get it? Next is a लिंकेज. लिंकेज म्हणजे ॲम्बिडेंटेंट आयसोमेरिझम. ॲम्बिडेंटेंट म्हणजे काय? त्यांच्यामध्ये ॲम्बिडेंटेंट लिगँड्स आहे. Ligands, that's the same ligand is bonded to central metal metal atom or ion through different atoms. पण same ligand आहे. Same ligand through different atoms. Same ligand is bonded to central atom or ion through different atoms. So this is linkage isomers. Get it? And it is also called the ligand that can bind through the more than one atom is known as the ambidental ligands. So this is shown by ambidental ligand. So this is NO2 and ONO. This is yellow color, this is red color. Get it? Because of the nature ambidental. And then other more ambidental ligands are cyano, and that's a thiocyanate. हे पण ambidental ligand आहे. So he forms the linkage type of isomerism. Get it? Next type is the coordination isomerism. Coordination isomerism. In coordination isomerism, there is an interchange of ligands between the cationic and anionic entities. Cationic and anionic sphere मध्ये काय असणार आहे? Interchange असणार आहे. So this is a coordination isomerism. So this is there is a 4 written as a 4 NH3 chromium cobalt. Get it? So this is the exchange between two ligand, that's the metal atoms, between two metal atoms. Another example लक्षात ठेवा. These are so many examples. Examples important लक्षात द्या. Examples हे क्वेश्चन तुम्हाला सीईटी ला पण विचारतील. ठीक आहे, त्यामुळे ते नोट करून ठेवा आपण. नेक्स्ट आहे हायड्रेट आयसोमेरिझम. हायड्रेट म्हणजे सॉल्वेट. इफ देर इज अ वॉटर, हायड्रेट आयसोमेरिझम. Hydrate isomerism, there is an exchange of water inside and outside the coordination sphere. Exchange of water molecule. Water is a ligand. Get it? So this is the water ligands. And these are the examples. Examples important है. So many types of examples. Get it? This is important example. Next is a theories in bonding, that's coordination complexes. VBT and CFT, valence bond theory, crystal field theory. Get it? So valence bond theory, VBT, valence bond theory shows the complexes are the form. These are the concept of hybridization. Get it? The steps involved in it. What are the steps? The metal ion provide the vacant d orbital. Get it? Then S and P orbital take part in hybridization. Then it's an equal number of the, that's the ligand donor atoms. And then if there is a, that's n minus 1d nd orbital used in hybridization allows the complex outer and the inner orbital complexes. So this is the outer orbital complex, nd orbital is used, and out, okay, inner मध्ये n minus 1d orbital are used. Get it? So these are the, that's actually steps. Next is the types of hybridization decide the structure of the complex. So what type of hybridization, then what is the that's the geometry. Structure काय असणार? Geometry of the complex structure. So if coordination number 2 असेल तर SP असेल, SP. Next is the tetrahedral. 4 there is written as both square planar and the tetrahedral. Get it? And 6, if there is 6, then there is the octahedral. So this is very important table for your decide the structure of the complex ion. So whether it is linear, tetrahedral, square planar or octahedral. Next is the limitations of VBT. What are the limitations of VBT? Or these are the VBTs. crystal field theory has been proposed which widely been accepted. It does not explain the high spin or low spin nature of the complex. So the strong and weak field nature of ligand cannot be distinguished. It is not provide any information explain the color of the coordination compound. Color. Get it? Low spin, high spin है, color है. The structure of complex PYQ from VBT will not always match necessary with those of determined from the experiment. The match होत नहीं, always is not match. Get it even? So these are the three limitations of VBT. These are the three limitations. Number one, high spin, low spin, color, and then that's not predicted from the experiment. Experimental and VBT different. Get it even? So CFT is used widely. CFT, crystal field theory. So what is the structure of complex compound based on VBT? So valence bond theory. The valence bond theory मध्ये first complex NiCO4. So this is CO is a strong field ligand. CO has strong field ligand है. So so therefore the what is the electron configuration for nickel? Nickel has a 3d8 4s2 in ground state. But oxidation state of nickel is a 0 oxidation state है. So selection of orbital in the nickel. Selection of orbitals in nickel atom for coordination. So what is the electron configuration? 3d8 4s2. 3d8 4s2. Get it? 3d8 4s2. So written as a 3d8 4s2 4p. And next as the that's a 3d10. So that's the pairing takes place. In excited state nickel electron pairing. So this is the pairing. Pairing of d electron occur because CO is strong field ligand. Get it? So there is a pairing ना, म्हणजे हा इलेक्ट्रॉन आहे, हा paired up होणार इथे. This is paired up आणि हा इकडे जाणार. म्हणजे this is the empty orbital. आणि ह्या empty orbital मध्ये ligands काय करणार आहे? इलेक्ट्रॉन प्लेस करणार आहे. Get it? So this is the CO. CO is the ligands. Four ligands. Get it? So this is pairing of the orbitals. Electron pairing takes place because of CO is strong field ligand. So this is the four ligands totally, carbon monoxide. And then in the hybridized state in this way. So this is a 4 empty sp3 hybrid orbital of nickel, but 8 electron donated by the CO and hence form the 4 coordinate bonds, that is ligand to metal complex type. Ligand to metal complex type. So type of hybridization का है sp3. Type of hybridization sp3. Get it? Type of hybridization sp3 in this way. Clear है? Check कर अपन समझने का. Okay, first return the oxidation state, electronic configuration. First return electronic configuration, then after the electronic configuration, oxidation state selection of orbital, and then pairing takes place because the carbon monoxide is a carbonyl is a strong field ligand. So the pairing takes place before hybridization. So nickel atom undergoes the sp3 hybridization in nickel tetracarbonyl. Get it? This is your, that's a type of hybridization. Next is the type of hybridization नंतर आपण draw करणार याची geometry. So tetrahedral ना. So tetrahedral in this case. So this is the tetrahedral. Nickel and then this is the tetracarbonyl. Get it? So molecular geometry of nickel tetracarbonyl is the tetrahedral. sp3 hybridization. Diamagnetic nature. What is the diamagnetic nature? Because it has no unpaired electrons. How there is no unpaired electrons? Here is no unpaired electrons. All paired. सर्व इलेक्ट्रॉन कसे सांगा paired आहे. All electrons are paired in hybridized state. ना all electrons paired. So it is diamagnetic. So magnetic moment how much? Mu is equal to 0. How? Because of this one, it is the ligand to metal type complex. A magnetic moment किती असणार? 0. So it is the under root n plus 2 Bohr magneton, 0 Bohr magneton. Get it? So it is diamagnetic. What is the complex? Diamagnetic. क्लिअर आहे? चेक करा आपण सर्वांना. तर ॲटलिस्ट यू शुड एबल टू राईट दिस पॉइंट्स. Next example is the NiCl4 2 minus. Same as it is same. Nickel as a oxidation. Okay, nickel as the electron configuration 3D8 4s2. Cl minus is the weak field ligand. So आता Cl हा weak field ligand आहे. Cl is a weak field ligand. तर निकेलची ऑक्सिजन स्टेट किती? निकेल NiCl4 2 okay 4 2 minus मध्ये +2 आहे. So written in this way 3D8 4s2. So selection of orbital in this way. Get it? And therefore the no excitation state because excited status नसणार याला का? Because Cl is a weak field ligand. No excited state because Cl is weak field ligand, and hence electron pairing in d orbital is not occur. Electron pairingच होणार नाही कारण Cl हा काय weak field ligand आहे. Cl is a weak field ligand. त्यामुळे डायरेक्टली जे एम्प्टी ऑर्बिटल आहे त्यांच्यामध्येच काय करणार आहे? Cl हे लिगँड्स इलेक्ट्रॉन ऍड करणार आहे, लिगँड्स. सो इन दिस वे, गेट इट? So what is the hybridization? sp3 hybridization. 8 electrons donated by 4 ligands. 8 electron donated by 4 Cl minus ligand. Hence from 4 coordinate bonds. That is ligand to metal complex. So the nickel atom undergoes the sp3 hybridization in NiCl4 2 minus. Get it? Clear? Once again, chlorine is the weak field ligand, so no pairing takes place before hybridization. No pairing takes place, so the electron pairing does not occur. Get it? So how many unpaired electrons? 2 unpaired electrons. So 2 unpaired electrons. So it is paramagnetic. This is 2 unpaired electrons, na? 2 unpaired electrons. It is paramagnetic. So this complex is paramagnetic in nature. Okay, now start the geometry. How do you determine the geometry? So this is a tetrahedral. Get it? So this is tetrahedral 2 minus tetrahedral nickel. Get it? And then molecular geometry of the is the tetrahedral sp3 hybridization. Paramagnetic nature है. Why paramagnetic nature? Because 2 unpaired electrons है. Because it contains 2 unpaired electrons. Magnetic moment greater than 0 है. Get it? Then how to calculate the magnetic moment? So this is the under root 2 and 2 plus 2. So this is the 2.8. Get it? So this is the magnetic moment. The 2 unpaired electrons say 2 unpaired electrons are same. The value 2 point something. Get it? So it is paramagnetic, very important paramagnetic. It contains 2 unpaired electrons. So this complex is a paramagnetic because it contains 2 unpaired electrons. 2 unpaired electrons. Get it? Clear? Then okay, Cl minus is the weak field ligand, so pairing does not take place before hybridization. Next is the NiCN4 2 minus nickel tetracyanide complex. So next complex nickel electronic configuration 3D8 4s2. Cyanide is the strong field ligand, so pairing takes place before hybridization. Nickel oxidation state +2a, so 3D8a 4h0. Get it? So nickel atom formation, then okay, this is the nickel. So pairing takes place. Na? Cyanide का strong field ligand है. So this is situation. So the cyanide is a strong field ligand. So pairing in d orbital occurs. Pairing takes place because it is strong field ligand. Get it? So what type of hybridization is there? So this is a sp3 type of hybridization. D2 sp3, D2 dsp2. Get it? This is the d orbital, na? One more orbital from the d. So it's a dsp2. So this is dsp2 hybridization. dsp2 hybridization takes place because 8 electron donated by the 4 cyanide ligand. dsp2 hybridization. And what is the geometry of the dsp2? So this is clear. dsp2 hybridization. How? Because the inner d orbital is used, na? Inner d orbital. This is the cyanide. This is 4 cyanide. Get it? In this way. So this is the geometry actually. This is the geometry of the NiCN4 2 minus. Get it? So this is the 2 minus. Molecular geometry of the NiCN4 square planar है. This is square planar. DsP2 hybridization diamagnetic. Ka diamagnetic because no unpaired electrons. No unpaired electrons, diamagnetic. Ligand to metal, and then how many unpaired electron? 0 na. So this is 0 over electron, diamagnetic. क्लिअर आहे. तर असे टोटल तुमच्या सिलेबस मध्ये 6 एक्झाम्पल्स आहे. तर प्लीज हे 6 एक्झाम्पल करून ठेवा आपण. ओके. CuNH3 सल्फेट. अमोनिया स्ट्रॉन्ग फील्ड लिगैंड है. 3d10 4s1. So what is the oxidation state? Copper +2. Copper 3d9. Get it? 3d9. So electron configuration 3d9. Next is the आता हा जो इलेक्ट्रॉन्स आहे तर सायनाइड हा अमोनिया स्ट्रॉन्ग फील्ड लिगैंड है ना. सो पेयरिंग टेक्स प्लेस बट वन मोर इलेक्ट्रॉन jump into this orbital. Okay, this is the orbital. Excited state मध्ये, in the excited state. So in the excited state, Cu2 plus electron pairing d orbital occur because NH3 is a strong field ligand. NH3 is a strong field ligand. So ammonia is a 4 ligand. So this is the 4 ligands. Donate the electron into the empty orbitals. Okay, so this is the DsP2 type of hybridization. DsP2. So okay, Cu2 plus atom undergoes the DsP2 type of hybridization. DsP2 type of hybridization. Get it? DsP2 म्हणजे स्क्वेअर प्लेनर. आता हा एक अनपेड इलेक्ट्रॉन आहे ना. तो दिस इज द अनपेड इलेक्ट्रॉन्स. So it is paramagnetic. So this complex is paramagnetic. Unpaired electron 1. Get it? So this is the 1 unpaired electrons. Okay, draw in this way. Square planar. Molecular geometry है square planar. Square planar geometry, hybridization DsP2. It is paramagnetic because of 1 unpaired electrons ना. 1 unpaired electrons. And value कितनी सांगा? 1.73. 1.73 under root. Get it in this way. So this is the 1 unpaired electron. Because of this 1 unpaired electrons, it shows the paramagnetic nature. It shows the paramagnetic nature. 1 unpaired electrons. This is the electron of next complex has the CONH3 6. Okay, cobalt. Cobalt has the atomic number 27, 3d7, 4s2. NH3 is a strong field ligand. NH3 is a strong field ligand. Get it? So electronic configuration of cobalt, but oxidation state of cobalt complex how much? +3. In complex +3. So 3d6, 4s2. Get it? So this is the cobalt is in the +3 oxidation state in this way. And next as a pairing takes place na. So this is the 1, 2, 3, 4 pairing on our answer. So this is the pairing takes place. Get it? So the pairing in d orbitals occur because why occurs pairing? Because NH3 is a strong field ligand. NH3 is strong field ligand. Pairing occurs because this is a strong field ligand. Get it? Pairing occurs because of the strong field ligand. Clear है? Pairing occurs because of strong field ligand. So empty orbital donate the okay, this is the total 6 ligands, na? 6 ligands. So what type of hybridization is there? D2sp3. D2sp3 type of hybridization. Total 6 ligand is 6 ammonia, donate the 12 electrons. So the cobalt undergoes the D2sp3 hybridization. D2 म्हणजे काय? Inner orbital complex आहे. Get it? Inner orbital complexes. So what is the geometry? Geometry in this way. Octahedral. This is octahedral. Coordination number 6, octahedral. Next is the octahedral geometry. D2sp3 diamantic है. Why diamantic? Because there is no unpaired electrons. All electrons are paired, na? All electrons are paired. So there is no unpaired electrons. That's why it is diamantic. It is diamantic in nature. And as a diamantic, effective atomic, okay, effective magnetic moment how much? 0. So this is the 0 Bohr magneton. This is very important formula. Then inner orbital, outer orbital, low spin paired complex. म्हणजे कोणते? So in the formation of this complex, the inner d orbital is used for hybridization. Then such a complex known as the inner orbital. Inner d orbital is used. And if the outer orbital is then called as the outer orbital complexes. Get it? This is the example of the actually outer orbital complexes. ठीक है. तो कोबाल्ट हेक्साफ्लोरो कॉम्प्लेक्स है. तो फ्लोरीन इज अ वीक फील्ड लिगैंड. फ्लोरीन हा काय वीक फील्ड लिगैंड है. यप, फ्लोरीन इज अ वीक फील्ड लिगैंड. So in this way, cobalt hexafluoro complex, same as it is. Cobalt 27 है, 3d7 4s2. Oxidation state cobalt है, COF6 3 minus plus 3, 3d6 4s0. So what is the return in this way? That's a CO cobalt plus 3. Then cobalt is in the ground state. So no pairing takes place, no pairing, because the cobalt, that's a, okay, fluorine is a weak field ligand. Fluorine is a weak field ligand. So no pairing takes place, no electron pairing in d orbital occurs. Because, what is the reason? Because F is a weak field ligand. Fluorine have weak field ligand hai. So he uses in this orbital, get it? So this is the orbital he uses. Get it? Okay, therefore the no pairing takes place, na? Total कितने ligands है? 6 ligands है. Total 6 ligands, no pairing takes place. Clear? No pairing takes place. So how many unpaired electrons left behind? 4. 1, 2, 3, 4. So it is paramagnetic. It is paramagnetic. 4 unpaired electrons is left behind. So what is the type of hybridization? Type of hybridization is the sp3d2. Total 6 ligand fluorine, 12 electron donation. Type of hybridization. What is the type of hybridization? sp3d2. sp3d2. So this is the outer orbital complex, na? Get it? So this is the structure. Then how to draw the structure in this way? COF. Get it? Yep. So this is the 3 minus octahedral complexes. Octahedral complexes, sp3d2, paramagnetic. Why paramagnetic? Because it has a 4 unpaired electrons. So this is a 4 unpaired electrons, na? Left behind. ये 4 unpaired electrons है. So because of this 4 unpaired electrons, it shows a paramagnetic nature. A magnetic moment greater than 0. So what is the magnetic moment? How much? So this is a 4 unpaired electrons. So this is a 4 under root 4, 4 plus 2, 4.89. So this is value 4.9089 Bohr magneton value. So this is the paramagnetic. Outer orbital high spin किंवा spin free complex म्हणजे काय? So in this complex, the outer d orbital is used. Outer orbital is used. बाहेरचं orbital वापरलं. Get it? So that's known as a outer orbital complex or high spin complex or spin free complex. Get it? Next has the semantic properties based on the VBT. So this is 3 unpaired electrons. Then it shows the that's a parametric character. Inner orbital complexes आहे D2sp3. Get it? यांचे अजून एक्झाम्पल्स आहे. आउटर ऑर्बिटलचे काही एक्झाम्पल्स आहे. Get it? एक्सरसाइज म्हणून करू शकता आपण. These are for your homework. Okay, get it? And these are the magnetic properties of coordination compounds based on CFT. The two degenerate orbitals say EG and T2G. Get it? CFT साठी आता this is CFT. CFT crystal field splitting parameter determine the magnetic properties of the coordination compounds. High spin and low spin complexes say. Get it in this way. So this is the that's the Fe3 plus as the F6 and a CN6. Get it? So this is the difference between this one EG and T2G. Get it? High spin complexes are more magnetic than the low spin complexes. So there is the three, okay, that's a EG and T2G orbital, and EG that's the T2G has the dxy, xy, yz and dxz, and this is the dxy, xz and yz or okay electrons. Get it in this way. So dx square minus y square and the dz square. So this is fluorine as a weak field, cyanide as a strong field. So pairing takes place, and in the F, that's the F6, there is no, that's pairing takes place. Get it? High spin and low spin. हाई स्पिन लो स्पिन कसा ओळखायचा? फ्लोरीन हा काय स्ट्रॉंग फील्ड आहे. सो दिस इज स्ट्रॉंग फील्ड लिगॅंड आणि सायनाइड काय वीक फील्ड लिगॅंड आहे. सो दिस इज वीक फील्ड लिगॅंड. So because of this nature the pairing takes place and no pairing takes place. So this is the pairing takes place and this is the no pairing takes place. Get it? Low spin, high spin. Clear? This is very important. CFT, this is CFT, crystal field theory. So because, what is the reason? Because F is a weak field ligand, 5d electrons enter into 5 separate d orbital with parallel spins, create high spin complex. And cyanide Cn minus strong field ligand है, so energetically prefer for the all 5 electron to be lower orbital and therefore the low spin complex. Get it? No distinctions like low spin and high spin complex can be made for D1, D2, D3, D8, D8, D9 and D10. यांच्यामध्ये काही चेंज नसेल. Get it? No distinction. There is no distinction between this. ठीक है, ॲटलिस्ट आता yes you should draw in this way. आता D1, D2, D3, so this is D4. So D4 ची केस ही असेल, हाय स्पिन लो स्पिन. D4 केस, D4 मध्ये अशी केस असेल, हाय स्पिन आणि लो स्पिन मध्ये. हाय स्पिन मध्ये पेअरिंग होणार नाही, लो स्पिन मध्ये पेअरिंग असेल. गेट इट? D5 ची केस अशी असेल. दिस इज द केस ऑफ D5, हाय स्पिन अँड लो स्पिन. D6 in this way. So this is the high spin and low spin. Low spin मध्ये पेअरिंग होणार आहे, हाय स्पिन मध्ये पेअरिंग होणार नाही, एक इलेक्ट्रॉन ऍड होत जाणार आहे. गेट इट? D6. and this is the D7 case. हाय स्पिन मध्ये लिगॅंड स्ट्रॉंग असेल, लो स्पिन मध्ये लिगॅंड, हाय स्पिन मध्ये लिगॅंड वीक असेल, लो स्पिन मध्ये लिगॅंड स्ट्रॉंग असेल. गेट इट? सो दिस इज द D7. That's the CFT, assumption of the CFT. So crystal field theory, ligands are treated as the point charges. CFT चे assumption विचारतो तुम्हाला 2 मार्कला. And there is no orbital interaction between metal and ligand. So this is purely the electrostatic. dxy xz, then same energy, that is they degenerate. No symmetrical and the degeneracy is destroyed. D orbital is split into 2 set different energies. T2G and EG orbitals. T2G and EG orbitals. So this is T2G 3, EG are 2 orbitals. Separation of these two energies known as delta O. O stand for octahedral. Delta O. O म्हणजे काय octahedral. Delta O depends on the strength of ligands. Crystal field splitting parameter. Get it? So this is strong field ligand. How to determine the strong field ligand? Because the strong field ligands, those having the donor atom C and P, and weak field ligand having the donor atom halogen, oxygen, sulfur. They causes the larger splitting, they causes the smaller compared to this one. Electron pairing takes place. Get it? So this is the electron pairing. Strong field, weak field ligand. An example, this ligand tend to form the low spin complexes. Low spin complexes to form high spin complexes. Examples important है. Example, cyanide NC, CONS3, DTA, ethylene diamine. हे सर्व strong field है. These are the weak field ligands है. Bromide, chloride, get it? Oxalato, these are the weak field ligand. Next is the ligand strength. What are the ligand strengths? The increasing field, ligand field. So this is the strong field ligand ना. Up to this एवढे सर्व काही strong field ligand आहे आणि हे काही weak field ligand आहे. So this is the strong field ligand. CO सर्वात highest आहे. Strong field ligand सर्वात जास्त कार्बन मोनॉक्साइड. Factor separating crystal field splitting parameter. Strength of ligands. Ligandची strength काय असणार? What are the strength of ligands? So that's a crystal field splitting parameter directly proportional to strength of ligands. Strength of ligands according to spectrochemical series. Get it? Spectrochemical series. Strong field ligands. Oxidation state of metal. Oxidation state directly proportional to crystal field splitting parameter. Directly. Higher oxidation state है, larger separation है. The trivalent metal ion causes the larger. Trivalent म्हणजे काय असणार आहे? 3+. Larger crystal splitting than the corresponding divalent. Divalent में +2 ना. म्हणजे oxidation state वाढली तर crystal field splitting parameter का तो वाढतो. Get it? This is directly proportional. So splitting of d orbitals and formation of octahedral complexes. So octahedral complex central metal ion surrounded by the 6 ligand. Ligand approach the XYZ, d orbitals resolve. Get it? With the closer approach of the ligand's axis, double D degenerate orbitals से explain the larger repulsion between the triple D degenerate orbitals. So this is the case. Get it? So this is the EG and this is T2G. आणि यांच्यामधलं सेपरेशन आहे हे काय? डेल्टा O. O stand for octahedral. O stand for octahedral. So this is the 3/5, this is 2/5. Okay, that's the 3/5 म्हणजे किती? 0.6 and this is the 2/5 म्हणजे 0.4. Get it? क्लिअर आहे? ओके, डायग्राम लक्षात ठेवा. EG आणि T2G आणि यांच्यामधलं सेपरेशन काय? डेल्टा O आहे. डेल्टा O म्हणजे काय? O स्टँड फॉर ऑक्टाहेड्रल. क्रिस्टल फिल्ड स्प्लिटिंग पॅरामीटर्स आहे. त्याच्यामध्ये व्हॉट आर द टर्म्स इन्व्हॉल्व? टर्म्स इन्व्हॉल्व आर द higher energy. EG is higher energy set of orbital. EG higher energy set of orbital. D xz and the dx square minus y square. And T2G हे lower energy orbitals है. And delta O, that's the 10 dqa energy separation between the two levels. And EG orbital are repelled by the amount of 0.6 and 0.4. This is repel and this is stabilize. म्हणजे Eg orbitals repelled and T2g orbital stabilized because it has a lower energy ना. That's the T2g orbital ची एनर्जी काय कमी आहे, T2g is lower, so the T2g lower stabilize आणि Eg is higher repelled. Get it clear आहे. आणि देन त्याच्यानंतर तुम्हाला यांचे लो स्पिन हाय स्पिन आहे फॉर इलेक्ट्रॉनिक कॉन्फिगरेशन. D1 D2 this electronic occupied T2g orbital obey the Hund's rule and this is 1 2 3 4 8 9 10 high spin low spin है, cannot be distinguished, but D4 to D7 important है high spin low spin complex ला, only D4 to D7. get it. so this is D4. तर D4 ची केस कशी असेल पहा, this is the D4 d orbital electron configuration high spin low spin. d orbital electronic configuration D4 है, तर हाय स्पिन लो स्पिन इन दिस वे Eg T2g. D4 हाय स्पिन मध्ये काय होणार आहे, पेअरिंग होणार नाही, लो स्पिन मध्ये पेअरिंग होणार आहे. सो दिस इज अ स्ट्रॉंग फील्ड लिगँड ना, म्हणजे इथे काय असेल, स्ट्रॉंग फील्ड लिगँड असेल, स्ट्रॉंग फील्ड लिगँड आणि हियर इज अ वीक फील्ड लिगँड, हियर इज अ वीक फील्ड लिगँड. गेट इट, वीक फील्ड लिगँड. So this is the strong field ligand, weak field ligand. Get it? You should able to distinguish between the strong field and weak field ligand. So D4 case अशी असेल, त्यामध्ये ती ओके 1 2 3 4 unpaired electrons, there is only 2 unpaired electrons. D5, so this is the case of D5. पेअरिंग लो स्पीड मध्ये होणार आहे, लक्षात घ्या पेअरिंग. तर D5 D6 D7 यांचे स्केचिंग आहे तुम्हाला, स्केचिंग क्वालिटेटिव्हली क्रिस्टल फिल्ड स्प्लिटिंग डी ऑर्बिटल एनर्जी लेवल आणि देन कॉम्प्लेक्स. आता डी हे कसं ड्रॉ करायचं पहा, तर याच्यामध्ये निकेल आहे, निकेल आणि EN आहे ना, इथिलीन डायमाइन आहे, त्याची ऑक्सिडेशन स्टेट कॅल्क्युलेट करा आणि ऑक्सिडेशन स्टेट नंतर कॉन्फिगरेशन फाइंड आउट करा, व्हॉट आर देअर कॉन्फिगरेशन. गेट इट. यांचं लास्ट इलेक्ट्रॉनिक कॉन्फिगरेशन फाइंड आउट करायचं तुम्हाला. इथिलीन डायमाइन EN म्हणजे इथिलीन डायमाइन. गेट इट. निकेल, निकेल सायनाइड आहे, सायनाइड वॉटर आहे. प्रिडिक्ट वेदर विच ऑफ द डायमॅटिक और पॅरामॅटिक, डायमॅटिक और पॅरामॅटिक. गेट इट क्लिअर आहे. आणि कलर ऑफ द कोऑर्डिनेशन कॉम्प्लेक्सेस, कलर कसे तयार होतात, कलर ऑफ कॉम्प्लिमेंटरी ऑब्झर्व द फ्रिक्वेन्सी द ऑब्झर्व. गेट इट, फ्रिक्वेन्सी म्हणजे फॉर्मेशन ऑफ ऑक्टाहेड्रल कॉम्प्लेक्स इज स्प्लिटिंग ऑफ द डी ऑर्बिटल इनटू T2g. And a separation of these two is measured by from experiment. Delta correspond to the certain frequency of electromagnetic radiation usually in the visible region. So that's why it shows the color. So this is very important point, color of octahedral complexes. So this is responsible for the delta O. Delta O म्हणजे काय, crystal field splitting parameter. A violet color of the titanium complex arises because of D2 transition. Explain why. Because the titanium plus 3 in this complex, titanium plus 3. So titanium plus 3 electronic configuration 3D1 na. So this is 3D1. So this is 3D1 from T2g excited into EG. EG electron, this is EG electron. Absorption of energy, this is so and so. So D2D transition takes place. So it shows the color. Get it? So absorption of wavelength of light correspond to delta O parameter and promote the electron from, that's a T2g level. So this shows the color, complementary color to the complex. Get it? This is the color with respect to coordination compounds. Next is okay, splitting of d orbital in the tetrahedral complexes. The tetrahedral complex मध्ये very important, tetrahedral complex मध्ये crystal field splitting आहे, तर dependent on the ligand's environment. Ligand's environment काय, so this is the ligand between the axis. The ligand हे between the axis येतात, ligand between axis, ligand approach between the axis in tetrahedral complexes, TD complexes. Get it? TD complexes. Ligand approaches between the axis. So there is opposite. So tetrahedral structure, metal at the center and 4 ligands. Get it? On the other hand, this is between the axis. Here orbital lie in between the metal ligand bond axis dxy, and this is the lying in the between the axis na. Toward the ligands. So the dxy xz orbital explains more repulsion. This is very important point. Okay, dxy xz yz orbital explains more repulsion than this orbital. Okay, so due to the larger repulsion, this orbital higher energy, while this is of the relatively lower energy. Get it? So this is the 6 dq and 4 dq 6 dq. So this is total 10 dq energy. Get it? So the splitting of the d orbital in that's a d orbital tetrahedral and octahedral complex. So splitting of d orbitals in tetrahedral and the octahedral complex is typically 4/9. This is very, very important. 4/9 compared to that of the octahedral environment. As compared to octahedral, it is 4/9. And this is the octahedral greater than tetrahedral. Octahedral greater than the tetrahedral. So this is the diagram actually. So this is the tetrahedral. Tetrahedral मध्ये काय करायचं? टेट्राहेड्रल मध्ये T2G वर लिहायचे आणि ऑक्टाहेड्रल मध्ये T2G डाऊन लिहायचे. गेट इट? सो दिस इज द डाऊन फ्री स्टेट मध्ये फ्री आयन आणि कॉम्प्लेक्सच्या फॉर्म मध्ये काय करायचं? ओके, डेल्टा TET टेट्राहेड्रल आणि दिस इज द O. तर एनर्जी किती असणार आहे? 4/9. सो दिस इज 4/9 हायर. So this is more stable. Octahedral complex is more stable as compared to tetrahedral complexes. EG and T2G. Okay. Complete. Okay. The crystal field splitting of the d orbital tetrahedral splitting as compared to the octahedral ligand field. The sparing of electrons is not favored in the tetrahedral complexes. Get it? Mostly is favor the tetrahedral structure. D8 configuration. Get it? Not found. Okay, that's the last part is the stability of the coordination compounds. Stability. Stability explained by the stability constant, ligand metal. Ligand metal interactions. So this is very important. Lewis base है. Metal ligand interaction stabilize the Lewis acid base interaction. So this is the equilibrium constant value actually. Equilibrium constant. So this is the equilibrium constant K. Stability of the complex can be explained in terms of K. Higher the value of equilibrium constant, larger is the thermodynamic stability of the complex ion. So this is the equilibrium constant. So the thermodynamic stability of complex directly proportional to value of equilibrium constant. Okay, this is the one of the question where this is the 27, 33 and 18. So this is most stable. Most stable. This is the value of thermodynamic constant. Equilibrium constant जेवढी जास्त असेल, कॉम्प्लेक्स काय असेल? स्टेबल असेल, मोस्ट स्टेबल. नेक्स्ट is the factors govern the stability of the coordination compounds. Charge to size ratio. Higher the charge to size ratio, greater is the stability. Charge to size ratio जेवढा जास्त असेल charge to size ratio, तेवढी stability of the complex काय असेल? Higher असेल. Stability of the complex directly proportional to charge to size ratio of the metal ion. Higher the charge to size ratio, greater is the stability. So this is the directly proportional to the charge to size ratio. Get it? So this is the Irving-Williams order. This is the divalent. Irving-Williams order is valid. Is valid for the divalent metal ion. Divalent stand for the two positive charge, and their stability shows the trend in this way. So this is very small size. Copper small size आहे. Cadmium हा झिंक कॅडमियमच्या खाली येतो माहिती ना. Zinc, cadmium, mercury. So the cadmium has a larger size. That's why the low stability. So this is Irving-Williams order. Charge to size ratio, not a size to charge. Always remember, not size to charge, charge to size ratio. Next is the size. Size कमी पाहिजे. Size कमी असेल तो yes, this is stable complex. Copper 2 plus forms stable complex than the cadmium 2 plus, because that's the charge to size ratio is greater than that of the cadmium. Okay, this is very important question. IMP question करा. Important question है IMP. Nature of ligand. The ligands is a more basic. So basicity of the ligands directly proportional to stability complex. Then how to determine the basicity of the ligands? So it is easily ligands can donate the lone pairs to the metal atom. Easily. So if we so he donate the easily, it is more basic. So stronger bases to form stable complexes. So the basicity of the ligand directly proportional to stability of the complex. Question IMP हा स्टॅबिलिटी कॉन्स्टंट दिली तुम्हाला आणि याची स्टॅबिलिटी 7 आहे 18.7 आहे का कारण बिकॉज ऑफ सायनाइड इज मोर बेसिक दॅन अमोनिया. दिस इज इम्पॉर्टंट. सो बेसिसिटी ऑफ लिगैंड स्टॅबिलिटी. साइनो कॉम्प्लेक्स more stable than amine complex because the Cn minus is more basic than ammonia. Get it? So this is the reason. Next is very very important, applications of coordination compounds. Applications of coordination compounds in biology. This is the chlorophyll present in plants. Magnesium है, hemoglobin, blood, iron complex है. नोट करा, this is important. Chlorophyll मध्ये magnesium, hemoglobin मध्ये iron, complex of Fe. In medicine मध्ये use as a treatment for cancer. Platinum complex, cisplatin. This is anti-cancer drug, na? It is used as an anti-cancer drug. Anti-cancer drug. Anti-cancer drug. Cisplatin. And used for treatment of lead poisoning. EDTA. EDTA is a hexadentate ligand. In medicine. Next, to estimate the hardness of water. To estimate the hardness of water, EDTA forms the stable complex with calcium and magnesium. Ions present in water, so can be used for estimation the hardness of water. It forms the stable complexes with calcium, magnesium, EDTA. Because this is hexadentate ligand, na? So we make as the chelation. Chelation stand for the ring formation. That's why it is most stable complex. So it is very easy to find out the hardness of water. Calcium, magnesium present in hard water. Get it? In electroplating, they on that's a dissociation. Smaller extent and gives a controlled supply of metal ions in solution. So this complexes is used for the silver plating, gold plating. So this is very important. Complex ची नाव लक्षात ठेवा. important, ही कॉम्प्लेक्सची नाव आहे. At least you should able to write that's a complex name. Cyanide complexes. Cyanide complexes dissociate to smaller extent and gives the control supply of metal ion. So there is a form of the uniform layer. Get it? So it forms the uniform layer. Get it even? So this is that's in electroplating. So this is related with the electroplating. Get it even? Is there any doubt? Then this is the last session. The last मध्ये तुम्हाला applications आहे. Applications of the coordination compounds. Get it? आणि हे क्वेश्चन सॉल्व करा आपण. ऑल दीज आर द क्वेश्चन्स. ते क्वेश्चन्स मी स्टार्टिंगलाच एक्सप्लेन केलेत, तर प्लीज हे पुन्हा एकदा रीड करा. आपण क्वेश्चन सॉल्व करा. नोट्स थ्रू तुम्ही बेटर नोट्स बनवू शकताय. गेट इट? तर नोट्स थ्रू ज्या नोट्स आता मी तुम्हाला शो केल्यात, तर त्यांच्या थ्रू तुम्ही एक चांगली बेटर नोट्स तयार करा. गेट इट? Get it even? These are very important for your upcoming board exam. ते क्वेश्चन सॉल्व करा आपण. दिस आर व्हेरी व्हेरी इम्पॉर्टंट क्वेश्चन्स. तर हे जे क्वेश्चन्स आहे ऑल क्वेश्चन्स तर मी एक्सप्लेन पण केलेत लेक्चरच्या स्टार्टिंगला. गेट इट? तर चेक करा आपण. हे सर्व क्वेश्चन सॉल्व करा. ऑल दिस क्वेश्चन्स नोट्स थ्रू एक बेटर नोट बनवा आपण. गेट इट? आउटपेजचे नेम असेल नंतर इफेक्टिव्ह ॲटॉमिक नंबर, आयोनायझेशन आयसोमर्स, नेक्स्ट इज बायडेंटेड लिगॅन्ड, मोनोडेंटेड लिगॅन्ड. गेट इट? नंतर कटायोनिक कॉम्प्लेक्स, अनोनिक कॉम्प्लेक्स, त्याच्यानंतर व्हीबीटी व्हॅलन्स बॉन्ड थिअरी. व्हीबीटी ओके. राईट द आयसोमेरिझम टाइप क्लासिफिकेशन ऑफ आयसो. ठीक आहे. आयसोमेरिझम, मोनोडेंटेड, बायडेंटेड लिगॅन्ड, इफेक्टिव्ह ॲटॉमिक नंबर, वर्नर थिअरी, linkage isomerism. Get it? Homoleptic, heteroleptic complexes, platinum complex. At least you should know this one. Diastereomers, cis and trans isomers. त्याच्यानंतर MCQ सॉल्व करा आपण. गेट इट? MCQ. This is more salts. Which of the following complex precipitate? Get it? Sulfate to form the white PPT. Effective atomic number. That's a cisplatin used as for the treatment in the cancer, anti-cancer drug. So it is as a anti-cancer drug. Now the effective atomic number is used to find out the geometry, stability of the complex, number of possible ligands. Get it? And then this is the tridentate ligand. Okay, this is the tridentate ligand, and this is the tetradentate ligand. Get it? नोट्स मध्ये शो केले पहा मी आपण. गेट इट? नोट्स चेक करू शकता. आयडेंटिफाय द कॉम्प्लेक्स, इफेक्टिव्ह ॲटॉमिक नंबर. ओके, व्हेरी इझी क्वेश्चन्स आहे. आयुपीएससी ने विचारतो तुम्हाला. नंतर कॉम्प्लेक्स. ओके, फॉर्म्युला. यू शुड एबल टू फाइंड आउट द फॉर्म्युला ऑफ द कॉम्प्लेक्स. गेट इट? सो द फॉर्म्युला ऑफ द कॉम्प्लेक्स, कोऑर्डिनेशन नंबर. ओके, व्हेरी इझी. तर हा चॅप्टर अतिशय सोपा चॅप्टर आहे. गेट इट? व्हेरी इझी चॅप्टर आहे. ॲट लीस्ट यू शुड एबल टू सॉल्व द क्वेश्चन्स. तर क्वेश्चन सॉल्व करा आपण. मी ज्या नोट्स शो केल्या त्या नोट्स एकदा आपण रीड करा प्रॉपर. गेट इट? आणि त्यांच्यापासून एक बेटर नोट बनवू आपण. व्हेरी 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 इम्पॉर्टंट फॉर युअर अपकमिंग एक्झामिनेशन. गेट इट? हे क्वेश्चन सॉल्व करा सर्व, ऑल क्वेश्चन्स. Okay, is there any doubt? Okay, no. Okay, thank you for joining us. Thank you. On the next session, started another from the physical chemistry, solid state solutions. Next with chemical thermodynamics, electrochemistry, chemical kinetics. Okay, in the next part. Thank you.